Oscillator, phase noise. So phase noise is a measurement of the power at an offset from the carrier frequency, and in the plot on the right there you can see the carrier frequency is measured in the top right as 99.99, so we can say 100 megahertz, and the carrier itself was actually 16 dBms. And then along the x-axis we're looking at a logarithmic scale of frequency shift away from that carrier. So the first line is 1 hertz away, and then the next chunk is 10 hertz, 100 hertz, 1000 hertz, and so on. And the yellow plot shows the power of the frequency components at that frequency offset. So the output is very similar to a spectrum analyzer, although you won't be able to measure phase noise using a normal spectrum analyzer simply because they don't have the resolution and they can't get that low. So you're going to need some specialist equipment to measure phase noise. This plot here was done on a Agilent 5052B, which I think cost us around the $100,000 mark. This equipment is getting quicker. When I started in the industry 20 years ago, it would have taken about an hour or so, maybe 2 or 3 hours on a really low phase noise plot to get an accurate measurement, and my engineers at the time told me that was very fast. These days, these measurements will take 5 minutes or so. On a really low phase noise plot, it will take longer to do the measurement. Might take an hour at most, I would have said. So yeah, it's getting quicker, it's getting better, but there's still needs a bit of time to do this stuff. When we are making a phase noise measurement, we need to be very careful about the test setup. Things like power supply, cabling, test fixtures, EMC shielding, these will all make an enormous difference to the measurements. When we do this, if it's a very low phase noise oscillator, we might use something like a lead acid DC battery for the power supply because they are very low noise. We might need to use fixed RF cabling. If I can tell you that if I twist the cabling, you will see the phase noise jump, especially at the close-in area. And any screening, I can measure the EMI radiation coming off strip lights, and CRT monitors were terrible for this in the old days. So yeah, very important to look at the measurement setup when you're doing this measurement. Yeah, generally speaking, the phase noise plot shows that there is more power concentrated towards the carrier and less as it falls away. We can say that this stuff close into the carrier is normally attributed to the resonator within the circuit, and the far out is generally attributed to noise coming from the amplifier and the silicon in the oscillator circuit, as a rule of thumb, that is.